Hey everybody, this is Mr. Piercy, and what we're going to be looking at in this video is how we develop the properties or the rule of one of our two types of special right triangles that we're going to be using in geometry. Now, this is a big deal, not just in geometry, but in math in general. We're not going to be doing two in-depth trigonometry. We'll be doing trigonometry with right triangles, but special right triangles and right triangles in general is kind of the foundation for a lot of the things that you'll be doing in trigonometry. So while special right triangles, you first originally learn about them here in geometry, this is one of the big things that carries over into future math classes, and it's very important that you have a good understanding of them now. I want to be clear that this video should only be watched after you have attempted to complete this investigation on your own. So you should not be following along doing the investigation as I talk about it. This is something that you should watch only after you've completed your own investigation, so that way you can kind of compare your results with mine. I've been struggling with how I wanted to try and make these lessons for you guys to watch because of its investigative nature. But I'm going to give this a shot and see how it goes. So right now I'm going to just go ahead and work it out and produce the answers that I would have given in class, and or if I had worked it out on paper myself, and then you can kind of compare your answers with what I've done. There will be a follow-up lesson that comes with this that demonstrates how we use the rule. But let's go ahead and get started here. Draw a right triangle where the legs are 1 unit long. Now it doesn't really particularly matter where you start. I think some of these investigations tell you a specific corner to do it from, and that's fine. So I'm going to draw a right triangle where the legs are 1 unit long. So this is 1 and this is 1. Classify the triangle by its sides and angles. Well, looking at it here, if I connect these together, that looks like a square. So and that's the type of dot paper that we have here. Instead of normal graph paper, we just have dots instead, but it does still create a square. So we have a right triangle, and because two sides are the same, I would classify this as a right isosceles triangle by its sides and angles. But what are the measures of the acute angles? So I want to know here, what's the measure here, what's the measure here? All right, so here's my answer somewhere. Come on, there we go. I'm saying that the acute angles have to both be 45 degrees. And the reason I'm saying that is because, first of all, it's a right triangle, so the two acute angles of a right triangle have to be complementary to each other. So here's a typo right here. This should be complementary. And because it's also an isosceles, the base angles have to be congruent to each other. And the only way they can both be congruent to each other and complementary is if they're both 45 degrees. So now, one of the things that I know students have a tendency to do is they'll have a tendency that they want to count diagonally to be the same length as a horizontal or vertical segment on this type of dot paper. And we know from the Pythagorean theorem that the hypotenuse cannot be the same length as the sides or as the legs. So use the Pythagorean theorem to find the length of the hypotenuse. So plugging in my numbers into the Pythagorean theorem, I'm going to say that in this case, the hypotenuse is the square root of 2 units long, or 1 radical 2, however you want to think of it. So draw a second right triangle where the legs are 2 units long. Okay, so we can pick pretty much anything that we want to here as far as where we do it. So let's do red. So now I'm going to say 2 here and 2 here, and closing it up gives me that. So this is 2, this is 2. Now, predict the length of the second hypotenuse. Now, this is where you guys would just, make a guess and see, well, what did you come up with? Well, looking at the dot paper here, because this length here is the square root of 2, well, this length here also should be the square root of 2, Same thing between those two diagonal points. That should be the square root of 2 also. So overall, it's 2 radical 2 units long. Now, what does the Pythagorean theorem say? Well, if you type this stuff somewhere, I have my, oh, here we go. Verify your prediction. So when I plug the side lengths into the Pythagorean theorem, I do get 2 radical 2. So 2 squareds give me the 4s. Add them together gives me 8. Square root of 8 can be broken up as a perfect square of the square root of 4 and the square root of 2. And the square root of 4 gives me a whole number 2 multiplied by remainder radical 2. We'll draw a third triangle and see what you see. So let me draw a new triangle here and let's see. So we're going to go 1, 2, 3 down, 1, 2, 3 over, and 3 like that. So again, this diagonal length. So here this is 3, this is 3. And here I have one diagonal length that's radical 2, another diagonal length that's radical 2, and another one that's radical 2. So overall, that whole thing looks like to me it will be 3 radical 2 units long. Well, what does the Pythagorean theorem say? Well, the Pythagorean theorem, if I type it into the, if I plug it into the Pythagorean theorem, 3 squared and 3 squared is going to give me 9. 9 plus 9 gives me 18. Square root of 18 can be broken up to be the square root of 9 times the square root of 2, and the square root of 9 is a whole number 3 with a remainder radical 2. So 3 radical 2 units long. So not too bad so far. We're able to, and that's the kind of the point of filling in the, looking at it on the dot paper the way that we are, so that we can actually see the physical length of the hypotenuse, or as the diagonal distance between the dots to be the square root of 2 units long. So now here, ideally, again, your table should pretty much be filled in once you get to this point. Again, you're just watching the video after you've done the investigation, kind of comparing your results with mine. So the first 3 are things that we did already, and now we're just using our inductive reasoning here to see, well, there's a pattern emerging. So I'm going to go, the next length of legs would be 4 and then 5. So their hypotenuses correspondingly would be 4 radical 2 and 5 radical 2. So there's the table that we would have filled in. Now some of you may have left the bottom row as 6, which is fine. A lot of students have a tendency to do that. But I left it as X simply because, well, I'm kind of looking to see how could I establish a pattern to use for any right isosceles triangle. And so instead of plugging in just another number, 6, I'm saying X. Now, I want to be super, super clear on this part. This part, number 9, this is the meat and potatoes of the lesson here. This is the big idea. So please compare your answer with mine, and if you agree with me, then great. If you don't agree with me, then let's talk about it. But this is the idea that what we want to kind of see. Again, we're looking at the table to see, well, how is it changing each time? If I know the length of the leg, I can figure out the length of the hypotenuse without really having to do any work, because every time I'm just taking the length of the leg and multiplying it by the square root of 2. Now here, the way that we read this part, the way that we read this is we read that as a 45, 45, 90 triangle. So my answer in a 45, 45, 90 triangle, the length of the hypotenuse can be found by taking the length of the leg and multiplying it by the square root of 2. And this, ladies and gentlemen, is the, this is the same statement written in a math format as opposed to an English format, but the hypotenuse can be found by taking the leg and multiplying it by the square root of 2. That is the rule that we will always use when we're evaluating 45, 45, 90 right triangles. So let's see part 10, test your conjecture. If a right isosceles triangle has legs that are 8 radical 2 units long, predict how long it will be as a radical number. Check your prediction by drawing it on the grid. Well, the rule says that the hypotenuse is equal to the leg times the square root of 2. So if we want to know the hypotenuse, I'm going to just say the leg, which is 8 units long, times the square root of 2. And since we're leaving it as a simplified radical number, I don't want the decimal value of that. I just say, well, the hypotenuse should be 8 radical 2 units long. And if we come here to check it, let's go ahead and clean this up a little bit here so that way I have space for it. So let's see, this is 1, 2, 3, 4, 5, 6, 7, 8. So I have to come down one more. And then 1, 2, 3, 4, 5, 6, 7, 8. Go back that way a little bit. So now my diagonal units, which are already 1 radical 2 units long, so that's 1, 2, 3, 4, 5, 6, 7, 8. So yes, if this is 8 and this is 8, then this would be 8 radical 2 units long. And we could very, very easily see that with the Pythagorean theorem. Okay. So let me go ahead and just put these back here in case we need them. Okay. So suppose each leg of a 45, 45, 90 triangle is x, express the ratio. Well, that's essentially what we had in that last column where I'm going to say x to x to x radical 2. Now there's going to be a follow-up lesson that demonstrates how we actually do the math with these things. And that'll be coming here very soon, so please make sure you watch it. But for the time being, hopefully you were able to work through the investigation okay. And if there was something that you didn't quite get the first time when you did it by yourself, hopefully watching this video kind of helped clear things up. And if there's still any questions about it, by all means, please let me know. But again, remember the big thing here is we're establishing a rule that says for any 45, 45, 90 right triangle, I can find the hypotenuse by taking the leg of the right triangle and multiplying it by the square root of 2. And that's the big idea that we're taking out of this lesson. So any questions that you have, guys, be sure to let me know. But until next time, thanks for watching and take care.